This module covers a lot of material. It basically covers parts of chapters 3 through 10 of the OpenStax text. Later videos in the series will provide more detail on the most important topics of the unit. The module explores some fundamental concepts in probability and statistical inference. Let's start with the basics. Probability is a way of quantifying the likelihood of an event occurring. It's a fundamental concept not only in statistics, but also in everyday decision-making in agriculture. Consider predicting the likelihood of a specific weather event affecting crop growth. Now let's broaden our perspective to probability distributions. These are mathematical functions that describe the likelihood of different outcomes. While several distributions exist, we'll focus on the normal distribution due to its common occurrence in natural phenomena. The normal distribution, often represented as a bell-shaped curve, is characterized by two parameters, mean and standard deviation. These give us a powerful overview of data distribution. Statistical inference is a critical component of data analysis in agriculture. It involves making educated guesses about a population based on samples. This process allows us to draw meaningful conclusions from field experiments, surveys, and other forms of agricultural data. Consider this scenario. You've tested a new fertilizer on a small plot of land. How can you determine whether the observed effects would be the same on a larger scale? This is where statistical inference comes into play. It helps in extrapolating data from a sample to a larger population. Two common tools in statistical inference are the z-test and the t-test. They are used to determine if there is a significant difference between sample means and if these differences can be generalized to the population. For example, a z-test might be used when comparing the average yield of a new genetically modified crop against a well-established variety, provided we have a large enough sample size and known variance. On the other hand, a t-test would be more appropriate for comparing the effectiveness of two different soil treatments in smaller pilot-scale studies, where the population variance might not be known.